All right, so sorry, the first video cut. Let's look at the difference between labeled and unlabeled data. You see, in machine learning, I am on a spree of machine learning, and then one of the things that we consider a lot in machine learning is labeled and unlabeled data. You know that when it comes to machine learning, we have supervised learning, unsupervised learning, and reinforced learning. And now, these three categories come in because of the kind of data you are dealing with and the kind of analysis you need to put on. So you see that in supervised learning, we are dealing with labeled data, or data whose characteristics is already known. The data that the data points have already been described and they have their labels already. Now, in unsupervised learning, we have a data whose characteristics or is not being labeled. No, we have not given any kind of label to that particular data. And so in those instances, there is a need for us to know what constitutes a labeled data and then unlabeled data. So I'm already sharing my screen, and then I'm simply just going to pull up my RStudio and demonstrate the two. I was doing something here. So I have this clear space which is here. And so what I'm going to do is that there is a data set which is, I want to show us two data sets, and one of them is found in ggplot2 package. I know that in R, if you want to load a data and that data is found in a package, you need to make sure that you load the package in the first place. So to load package in R, to do library. So you ggplot2. I want to as I need to now this set is a labeled data set. It's labeled. It has been labeled. It has been described. Now, on the contrary, let's look at another data set which has no label. And so let's look at the iris data, the popular iris data. So you can see that one is that one comes with R itself. So it's a default data. So it's just there. You don't need any package. It doesn't come with any package. So what I'm going to do, I also want to do a head of the iris data. And in this case, I'm also looking at just 10 lines, the first 10 lines. So now let me pull this up and we look at the difference here. Now, if you look here in any data, these are data frame. The two of them are data frames. So this is a table. That's why you are seeing all these things on top there. It has been characterized. So here we have, these are variables. The column headers are what we refer to as variables. You can also see the column headers here. They are all variables which have been created. So now when we come, we can see that this particular character that we have here, or this variable we have here, the data points here describe a particular variable. So just the same way. So we are looking at the character, we are looking at the cat with the color. This is actually a diamond, and then we are looking at the various characteristics of a diamond, and then we look at it all the way up to the last point. If you want to have a clear definition of what all these variables are, mostly what you do is, in data science, you simply ask a question. For instance, if you want to know what the diamonds data, what are they standing for, we could just say, I could just put a question mark like this, and then I'm just going to say diamonds. Okay. And then, so when I run that, it's actually going to, it pulls up So let me fold this up, and you can see the description of all the variables which are there. So if you look at the carat, it needs the weight of the diamond. So it ranges from 0.2 to about 5 point something. Then the cut actually measures the quality of the diamond, and this one, the measure is fair, good, very good, premium, and ideal. We also have the color, that's the diamond color from D best to J west, and so you can see the clarity. So that is the measurement of how. So this part gives you the characteristics of that particular data. Now let's come here and also try to find out the data. Of course, we can also look at the characteristics of the iris data, which is also found around here. You can see we have the iris 1 and the iris up to iris 3. So we can see all the description of whatsoever that is there. Now, that is not what our interest is. Our interest this evening is to establish how do we know if a data set is a labeled data or level. The question I know people are asking right now is, so the two data have how do label and unlabeled data is data that is labeled has a different variable. I mentioned that all variable, this variable and this object or the argument or I've already shown how that's satisfied. So we have here, then that's the measurement of, we are looking at the measurement of the weight starting from 0.2 in that order. The cut tells you the quality, whether it is ideal, premium, good, whatsoever, and then you can have it down here. So the data points have been labeled and it has been described. Here, when you also come, we are just measuring. If you look at the data here, it gives you a clear description of what you are talking here of the want all of that actually gives a label of that particular or of that particular thing that you are looking at. In this case, we're looking at a diamond. So this is of diamond, and we've looked at the weight, the quality, and the color, and whatsoever. So you see that they just be repeated. When you come here, when you come to the other part, you also have the variables on top there, but it tells you sepal length. So this is sepal width. This is not one thing. Here we are talking about okay, now, let me not go through this side. There are also variables anyway, which also have their own, description, which is also down here. Okay, and so this is a flower called setosa, sepal length and whatsoever up to this point, and then sepal width of that particular up to that point, and then it's the same flower. Now, so if this are labeled, these are labeled, so why are we between reading? Then the difference is that labeled data have dependent variable. All labeled data do not have dependent variable. A dependent variable is the variable of in the company to have all right. bad. It's so bad today, and so that's why I'm having these challenges. So let me just continue. So I was here and I was talking about the difference between a dependent variable, a labeled data and unlabeled data. And of course, I pull up my RStudio and I was trying to explain this. So a data is called labeled if that data has a dependent variable in it. And so everything that you are measuring there, you want to find out how the dependent variable can be explained by using the independent variable. How do the independent variables influence the dependent variable? And that is it. So the dependent variable depends on the independent variables for it to be the way it is. So the price of this diamond depends on the quality, the cut, the carat, the clarity, the depth, and the table. And that's what I am talking about. So in that case, if I have to price it at, let's say, 326 Ghana cedis, the price will depend on all these qualities. And that's what we call a labeled data. So when you see a data that is labeled, there must be a dependent variable in it. There must be either one or two dependent variables that you want to measure. So if you come to unlabeled data, there is no dependent variable. Each of them is independent. They are independent of each other. None depend on the other one. For instance, we cannot hear this. These are parts of a flower, and the name of the flower is setosa. Now we cannot say that the setosa or the petal width is 0.2 because the petal length is 1.4. No, I mean they are just measurement. There's no label. We don't have any variable that is dependent on the other. So they are independent variables. And so because all of them are independent variables, we say that they are not labeled. They are not labeled data. So you can't actually perform any kind of regression analysis in it. Maybe the highest you could do is to do a correlation, but you can't do any regression analysis at this point. So that is the difference between a labeled data and unlabeled data. Let me also put this quickly. To say a data is labeled, it depends on you, the data, the owner of the data, and whatever information you want to pick from it. For instance, if I decide to pick my data here, or if I can decide to also say that this is also a labeled data, and I will have to explain how the sepal length depends on the rest. So once I pick one of the variables as a dependent variable, and then the rest are independent, and then I am performing some kind of analysis in which the dependent variable is explained by the independent variable, then it means I am talking about a labeled data. So for instance, if I pick, let's say I can just create a table right now, or I can just create some kind of a data now, and then we look at something there. I don't know if I can pick this data as quickly as possible. Yes. I'm just going to pull up some data from somewhere quickly and then do some kind of. Alright, so I'm going to come here and then I'm just going to copy it. So it's being copied right now. I'm getting back to my RStudio and I'm going to do this. So I'm just going to say what is it, MF data, and so what am I going to do? I'm going to do read dot delimiter, and then I'm going to because I've already copied from my clipboard, so I'm going to say clip my clipboard, come here, and then I'm going to say my separator is equal to this, and then that is all. So let me get back to that particular data and copy it once more. So you see that I have copied it. So now the data will be is going to be in my clipboard. So now if I come here, I can just, and so now if I decide to have a head of, let's say, I'm just going to have a head of the data, which is MF data. So you can see the data set is actually here, but I think it's not well copied. It's not well copied, so I'm going to copy it once more, and then okay, maybe I can come here, and so let this open, and then I will just show you something. So I'm going to come here, and then I'm going to paste it. So the data is being pasted around here. So what I'm now going to do is I'm just going to highlight from here up to this point, and then copy it again. So I'm going to my R, and then I'm going to run that again, and I'll come and run this again and see how it's going to look like. It's still not properly copied, so maybe I should close up this space here and then run it again and see this. I just want to make sure that here, well, so here it looks a little bit better. It looks a little bit better, and so let me check the structure and see what kind of structure it is. And so MF data, so what structure is it? They say it's a data frame, so that is great. So now if you come here and then you look at something here, the data set that just like we have, I think the separator is not properly done. The separator is not properly done. I wish that, okay, the separator, let me put it R, comma separated, and see what is going to happen. No, let me leave that, and then let me just leave a space here, run it again and look at it. Oh no, so I need to close the space up, and then that looks a little bit better. Okay, so now if I have this, what I have here, that's the name of the string, that's the context side, and then that's whatsoever that is here. Now if I look at just only these these columns here, 1 2 3 4 5, and then perhaps let's say 6 or something like that. So I'm just picking column 1, column 2 3 4 5 6. So from column 2 to 6, I'm taking that one out. So this is what I'm going to do. I'm going to create a new variable called mf, and then MF. And so what I'm going to do is that I'm going to say the MF, so the MF data that I have, I just want to pick from 2 to 6, and then into, so that when I come, we can now all look at MF and see how that looks like. So now come and look at something here. This is what I was talking about. This data, as we see here, these are contigs, these are genomes, these are sizes, the genome sizes, these are the GC content, and of course we also have the transfer RNAs. This data is not labeled. Okay, none of them depend on the other. We do not have any of them being a dependent variable on the other. We don't. So because of that, it is called an unlabeled data. But immediately we have a particular variable here which is dependent on any of them, then we can begin to say that it is a labeled data. So a labeled data always have a dependent variable, and the dependent variable would be explained by the independent variables, either by their interaction or by their individual influence. And that is why in data analysis you would have to make sure that you know the kind of data that you have, and then whether it is a labeled data or it is not a labeled data, before you can begin to have before you can go ahead with whatever analysis that you wanted to do with it. And that's what I wanted to do. So I could just I could have just, why, I don't know why my view is not showing. I don't know what the problem is, but So this is basically how we are able to differentiate between a labeled data and then unlabeled data. There must be a dependent variable there. And now let me explain on another way. Is much more of what you yourself have described the data to be. Just like I have shown you here, if I had these are the genomic features of a bacteria, and so I have the contigs, I have maybe I'm looking at the number of contigs. So the number of contigs, do they have anything to do with the genome size? Does it mean that if the genome size is that much, what is it? Will it is it going to have some kind of effect, or is it going to have some kind of does it result in the number of contigs? Or what about the GC content? And what about the transfer RNAs? So once we do not have each of them do not have any kind of dependence on the other, and there's no dependent variable there, then we can simply say that that particular data is not labeled. But immediately we have put all this together and we say that, well, we have a variable here, and that particular variable is explained by the interaction or by the influence of the rest of them, then we can now call the entire data set as being labeled. I mean, let's get this quite, what is it? So for instance, if I pick a data set of students, and then I just pick their height, their, I say this is their height. So if I were having, let's say, student characteristics, and I just look at their height. So the height, let me put HT, then I put the height, let me say, I have their weight, I have their complexion, and then I have, let's say, their foot length or their feet length, then if I have all these characteristics of the students, what is it? It becomes an unlabeled data. So, but immediately I now bring something like performance. Okay, and then I want to check whether the performance is due to the height of the student, the weight of the student, the complexion of the student, and the feet length of the student. It means the entire data set becomes a labeled data, because there's a dependent variable here, and that dependent variable becomes what? Performance. So it's not as if when the data set comes, it's already being described, or that has been described. You can have a data set which is, let's say, somebody may consider it as unlabeled data, and then you could pick it and consider it a labeled data. For instance, this particular performance, if I don't treat it as having anything to do with the height, the weight, and the complexion or feet length of the student, what is it? For me, it's not going to be a labeled data. So it's only the labeled data and unlabeled data is differentiated based on the presence of a dependent variable. And that dependent variable is defined by you, the owner, or you, the analyst, and what you want that particular variable to do. Maybe you have noticed that somebody may look at the whole of this and say that, no, I don't see any kind of correlation, or I don't see any kind of relationship with all this. But somebody may want to test it, may want to test the data to find out whether the performance of students, does it have anything to do with the height of the student, or the weight of the student, or the complexion, or the feet length? Maybe, so immediately you're going to test that. Then you realize that the whole data becomes what? A labeled data. I am emphasizing on this because once we are able to distinguish or to know which data is labeled and which data is unlabeled, then we will know that once it is a labeled data, it can come under supervised learning. And in that case, you can only do classification, you can do regression, and you can do decision tree, and then whatsoever. At the last part, you can do a confusion matrix, or you can look at the model accuracy and whatsoever. If it is a regression, you may want to have at the last. For instance, come and look at something I have done here. If it is a regression, you may want to have finally your root mean square error and then you want to measure how your root square, what the root mean square error, how it's going to look like. If it is a classification, you may want to look at your confusing metrics, and then that confusing metrics will actually give you your output. You can use the confusing metrics to be able to calculate the accuracy of the model by using your leading diagonal divided by the sum total of the other confusing metric variables, and then you are getting your model accuracy. And then you know that, okay, whatever the model is predicting, it is 80% accurate or it is 90% accurate, and then in that order. So that is how we are able to to put the data, whether you are going to use it to analyze it under supervised learning or unsupervised learning. So you realize that the two data sets, like in the diamonds here, if I'm going to analyze it, because the diamonds, let me run it again, because the diamond data set is a labeled data, I can only do supervised learning here. So in that case, I'll look at all the algorithms and the supervised learning, and then make sure that I apply those ones. Here, then I can do a regression analysis. I can do a linear regression. So by putting price as my price will be my dependent variable, trying to what is being explained by the rest of the independent variables. That is, I mean, the price of the diamond being explained by the weight of the diamond, the quality of the diamond, the color, the clarity, the depth, and then the table of that particular diamond. So that is what that means, and that's why I can use regression to be able to do this analysis. In any case, there could have been another way of also explaining this. All right, and so that's one basic thing that I want us to know. Now, when we go to the iris data, which is also here, you realize that this particular data, it is not labeled. We don't have any dependent variable in it. So what can we do? We can possibly do the kind of machine learning we can apply here will be on supervised learning. And then on supervised learning, we are looking at association analysis. We are looking at a clustering. So in that case, we can only do some clustering here. And the clustering would simply put the data based on similarities. Those that are very close, they will put that will be put together. And those that are wide, those that are, it will classify or to put all the data into some kind of classes or some kind of clusters. And then the classes will be based on similarity. So in that case, let's say if I were having the students, like in the case of the student data set I was talking about here, so here, if we didn't want to take performance as a dependent variable, so all we could do is we just have all of them. We just can do what we call unsupervised learning here. So under the supervised learning, it will classify all the students who are short, classify all those who are tall or who are not tall or not short, maybe medium height, classify all those who are heavy, and then those who are are less heavy, those who are light and whatsoever, based on the weight. It will classify them based on complexion, those who are fair, those who are chocolate, those who are dark like me, and those who are maybe black. You see, and then the fit length, it will also do that kind of classification, and that's what to do that kind of clustering. So it will cluster the student based on where we have similarities and then where the similarities are quite closer. And that's why when it comes to unsupervised learning, you are looking at clustering, you are looking at a principal component analysis. These are dimension reductions, so they only reduce the data into much more similar ones, and then we can do some kind of association analysis, and association in such a way that you want to find out whether the length of a sepal length has some kind of association with maybe with the width of the sepal length, or so is there any kind of association? Or so if you notice that in this kind of data sets, mostly the kind of analysis we can do here will just be a correlation analysis. And that is why when it comes to unsupervised learning, mostly the data, if it is in a data frame form, you have to transform it into matrix. And once you are transforming it into matrix, it rings a bell that kind of analysis you are going in is either correlation. You don't do regression with matrix data, but you can do correlation. The correlation here means that you want to find out whether there is a co-occurrence, whether when one is occurring, does the other one also occur. You see, but it is not being explained. For instance, do you want to find out whether anytime there is wind blowing, does it result into rain? It doesn't mean that the rain or the wind is what influences the rain. No, the wind actually blow in the dry season. But you want to find out whether there is a correlation between wind blowing and then rain. All right. So, but there are when you are explaining, if you want to do that kind of analysis where you are doing correlation, co-occurrence of something, then you are actually dealing with something that has to do with independent variables. So all the variables, they don't have any dependent. None of them is dependent on the other one. So you can only find out their co-occurrence. If one is occurring, does the other one also occur? If one is not occurring, does the other one too not also occur? But that doesn't mean that the occurrence of one automatically necessitates the other one. You see, that is why independent variables are being analyzed. It's different from where you have a dependent variable that is being explained, like prices, like height, like weight, like all those things that has some kind of dependence on another thing, like student performance and whatsoever. And so you can see that people may want to look at student performance based on whether they come to class all the time, they don't come to class, whether they read their books, whether they have access to laptop, whether their fees have been paid, or whether they come from village or they come from town or whatsoever. And then that is how it is. All right. So another thing that I wanted to pay attention with labeled data and unlabeled data is that in most labeled data you will find categorical kind of data there, like yes or no, like bought, did not buy, performance, it performed or it did not perform. You can find something like this or that. There are always a categorical data. What is the data over there? So when you see those things, it rings a bell that data is labeled, because you will have that categorical data there, and then that allows you to be able to do your analysis. I will bring in another form of the way of identifying these kind of data sets and then how to be able to explain them in another form. So this is one part. So in this part, my summary before I run out is that a data that is labeled will definitely have a dependent variable. I've already described the dependent variable. A data that is not labeled mostly will not have dependent variable. All the variables are independent. None is dependent on the other. So, and if you know that the data set is dependent or is labeled, you know the kind of machine learning algorithms you can apply. If you know that the data is not labeled, you will know the kind of machine learning that you can apply. Labeled data are usually used in supervised learning. You can use regression there, decision tree there, and whatsoever, classification, and then the k-means, and all of them are applied there. Now, when you go to unlabeled data, like I've given, that can only be used in unsupervised learning. In that case, you are looking at clustering, you are looking at principal component analysis using k-nearest neighbors and whatsoever. And that is how it is. You can use artificial neural networks and whatsoever. That's where we apply that one. And so if you get a difference, thank you very much, and then have a good night. All right, so that has been the difference between labeled data and unlabeled data. I hope you get it. I'm sorry the video is quite long because the internet is breaking, so I keep going off and on, and that is why it has happened this way. So that is it. So tomorrow I'll now go ahead and then start bringing you some of the models and then the real data and how it's been the real analysis of all that I have. I will start with supervised learning, where we'll be using classification, regression, and then whatsoever. And then after that, I'll go to unsupervised, where we'll look at clustering, principal component analysis, and then using these k-nearest neighbor functions and whatsoever. All right, so thank you and have a good night.